copper rod is inserted into a hollow aluminum cylinder. The copper rod projects 0.005 inches as shown. What maximum load P may be applied to the bearing plate? Use the data in the following table. So, load P yung hinahanap natin, or P, or maximum load P. And then, it's the figures. Ito na lang ulit. So, ang figure niyo is ganito. Ang figure niya ay ganan. Tapos may agwat siya. Exaggerate ko na lang siya. Tapos andito yung load P. So, ito, block yun. Tapos ito, copper. And then, itong dalawa, aluminum. So, sabi dito, yung length nito is 10 inches. And then, yung agwat nitong dalawa is 0.005 inch. So, here, maglagay muna tayo ng deformation. Halimbawa, imagine lang natin, nakuha na natin itong P max, which is ito yung hinahanap. So, ang hinahanap nga sa problem is this P max, pero kailangan natin i-compute this deformation. So, imagine lang natin, nakuha na natin yung P max, and yung itong block na to is hindi siya hinaya or umisod siya papunta rito, and yun yung magiging deformation. Hindi siya hinaya ng copper and aluminum, at umisod na nga siya pababa. Doon tayo kukuha ng deformation. Halimbawa, dito na bumagsak yung block na to. Dito na siya napunta. Because of the load P. So, eto, mula dito, papunta rito, ito yung deformation na mangyayari sa copper. While, ito naman, hanggang dito, ito naman yung deformation na mangyayari sa aluminum. So, meaning, yung deformation ng copper natin na ito, block na ito, is equals to this one muna, plus yung deformation na mangyayari sa aluminum. So, deformation ng aluminum plus 0.005 inches. So, ito yung magiging equation natin for the deformation later. Then, when it comes to force naman, drawing ko na lang ulit siya. So, kapag sa force naman ang pinag-uusapan, may P yan. May load siya rito P. Then, di ba, bago bumagsak itong block na to dito, which is this one is copper, this is aluminum, and this one is aluminum. Bago siya bumagsak itong block na to, itong block ng copper dito is nagre-resist muna siya. Which is, yung tatawagin natin na P copper, or yung force ng copper na magre-resist dun sa block. And then, kapag itong block na to, dumating na siya sa point na to, bago pa siya makapag-form ng deformation, ito munang block na aluminum, itong dalawang ito, is magre-resist din muna siya dun sa block na to. So, yung resist nito is PA, and this one is PA. So, nakikita lang naman natin dito, yung forces nila is pataas and pababa. Meaning, itong force ng aluminum, force ng copper, is dapat equal siya sa force ng P max para hindi sila makapag-form ng deformation or maging equilibrium lang sila. So, P max, it is equal to PC, or force na i-resist ng copper, and also plus the force na i-resist din naman ng aluminum. Yan. So, ready for the computation na tayo and substitution. So, kapag nag-compute ko siya ng deformation is may sinusunod lang ang step. Step number 1 ko is form the equilibrium. Okay. So, sa equilibrium, alam naman natin na dapat vertically and horizontally is equals to 0 always para magkaroon tayo ng balance forces. So, kapag equilibrium, ang pinag-uusapan lang natin is force. And nakakuha na rin naman tayo rito nakakuha na tayo ng equation which is subjected lang siya sa forces, which is this one. So, this equation will be our equilibrium. Baka nag-English. So, eto na yung equilibrium equation natin. Then, step number 2 is the compatibility. Ang compatibility na sinasabi rito is yung kung ano yung na-form mo na equation for deformation, which is this one naman. Ito na yung na-form natin na equation from the figure. So, sulat lang natin. This is the compatibility. Then, the third step is the Hooke's law. Yung Hooke's law is magsasubstitute lang tayo ng formula nitong nasa taas na deformation. Diba, ang deformation formula is PL over AE, which is dapat subjected siya sa copper. Kaya lagyan na lang natin siya ng palatandaan C. Then equals to deformation of aluminum. Formula ng deformation of aluminum is PL over AE. And yung palatandaan na lang natin is lang natin ang letter E. And plus natin C 0.005 inches. Then, dito kung mapapansin ninyo dun sa formula ng deformation, itong part na to is stress siya. Diba? Ang stress is equals to P over A. So, instead na, ito yung gamitin natin, ilagay na lang natin is stress para mas madali siyang mag-substitute. So, stress of copper times length of copper over elasticity of copper is equals to stress of aluminum times length of aluminum over elasticity of aluminum plus 0.005 inches. So, sa given din natin is kailangan natin i-consider yung binigay na stress limitations, which is ang stress limitations for copper is 20 KSI or 20,000 PSI rather. PSI. Kasi 1 PSI is equals to 1,000 KSI. And then, stress of aluminum is equals to 10 KSI or 10,000 PSI. So, itong given na to, na binigay sa problem, this will be the limitations na dapat magkaroon tayo na stress. Halimbawa, pag may nakuha tayong stress ng copper na greater than 20,000, meaning mali yung stress na ginamit natin sa equation. Kailangan nating makakuha ng equal to or less than for these values. Proceed niyo tayo sa substitution ng mga binigay na given din sa table. So, sulat ko na lang ulit yung equation natin, which is stress LC over AC is equal to stress of aluminum times length of aluminum over plus 0.005 inches. So, ang stress, hindi muna natin ilalagay stress ng dalawa. Ang much better na Much better na ilagay lang muna natin itong dalawa kasi kapag sinubstitute natin lahat ng given, including the stress of both, is makukuha natin dito is simply a number and hindi natin makukuha yung kinukuha nating P max. So, lagay muna natin si stress, which is yung length of copper. Length of copper, balikan tayo sa figure, diba? Diba ito yung copper? Ito yan, yung copper na yan. Tapos sabi, etong length daw ng aluminum is 10 inches na. So, meaning, this one is 10 inches. Tapos yung agwat nila dito is 0.005 inches. Meaning, this one is 0.05 inches. So, yung 10 inches, add lang natin to para makuha natin yung length of the copper. So, 10 plus 0.005 inches is equals to 10.005 inches. Then, elasticity ng copper is given naman, which is 17 times 10 raised to 6 is equals to stress of aluminum times natin siya sa length of aluminum, which is, ang meron sa given is 10 inches over elasticity of aluminum na 10 times 10 raised to 6. 0.05 inches. So, ang next step natin, simplify muna natin itong dalawa or ito. Or kahit huwag na tayong simplification, i-diretso na natin sa calculator. Next step natin is trial and error. Isa-substitute natin yung binigay na value ng stress ng copper and stress ng aluminum para may makuha tayong true value ng dalawa. Halimbawa, first trial and error. Ginamit natin yung value ng copper is equals to 20,000 PSI. So, i-substitute lang natin. Substitute natin yung value ng copper. So, 20,000 times 10.005 over 17 times 10 raised to 6 is equals to aluminum. Stress of aluminum times 10 raised to 10 times 10 raised to 6 plus 0.005 inches. Then, for simplification, ang makukuha natin na value ng stress of aluminum is equals to 6,767.60 PSI, which is, this value is mas maliit siya dun sa naging original value kanina ng stress ng aluminum, which is, sa given, meron tayong 10,000 PSI. And nakuha natin dito is 6,000 lang, meaning this will be the true value of stress of aluminum. So, pag nakuha na natin yung true value ng stress aluminum, meaning tama rin yung ginamit nating value ng copper. So, we have the true value of the two stresses. Halimbawa, ang inuna muna natin is, nag-trial and error muna tayo. Ginamit muna natin is value ni aluminum with na 10,000 PSI. Then, substitute natin aluminum, stress of copper, then 10.005, 17 times 10 raised to 6, then aluminum, stress of aluminum, 10,000 PSI, times natin siya sa 10 over 10 times 10 raised to 6 plus 0.005 inches. So, for the simplifications, ang makukuha nating value nitong si stress ng copper will be equal to 25,485.75 PSI, which is nag-exist siya dun sa binigay na given value ng stress ng copper stresses, which is 20,000 PSI lang dapat. Eh, mas lumaki siya rito sa naging value gamit yung value ng stress ng aluminum. Meaning, this is wrong. This is the wrong value of the stress of copper, and this one is also wrong for the value of the stress ng aluminum. So, to proceed, itong value dalawa na to ang gagamitin para makuha natin ang value ng force ng copper and force ng aluminum. So, proceed. Meron na tayong stress ng copper which is 20,000 PSI and stress of aluminum which is 6,767.60 PSI. And ang formula ng stress is equals to P over A or force over area. So, subjected natin siya sa copper. Then, ang gusto nating makuha is this one. And may value na rin naman tayo ng dalawa, kaya pwede natin kuha. So, 20,000 PSI is equals to PC over yung area ng ating copper is 2. So, cross multiplication lang natin siya. Then, we can have the value of PC, which is 2 times 20,000 is 40,000 PSI. Then, proceed tayo dun sa kabila, which is stress of aluminum is equals to force of aluminum over area of aluminum. The stress of aluminum is 6,767.60 is equals to PA over area ng aluminum is 3. At ito ang nahanap natin, cross multiplication. Force of aluminum is equals to force of aluminum is equals to 20,302.80 pounds. Oh my gosh, mali ito. Pounds to. So, for the solution of Pmax, diba dito sa equilibrium natin, yung Pmax daw is equals to force ng copper plus force of the aluminum. Makukuha na natin si Pmax. So, Pmax, or maximum load of P, is equals to, addition lang natin, 40,000 pounds plus 20,302.80 pounds is equal to Pmax is equals to 60,302.80 pounds or 60.30 kips, because 1 kips equals to 1,000 pounds. So, this will be our final answer. And thank you.